All right, we are in section 12.3, where we get to now analyze geometric series and sequences. So in section 12.2, we talked about arithmetic sequences and series. Arithmetic sequences and series we talked about was when we had a common difference where we could add or subtract. The pattern to create the nth term for each of those sequences and series. For geometric sequences and series, it's very similar, but instead of recognizing it through addition and subtraction, we must have a common ratio which comes through multiplication or division. So for this first part of the homework, they're going to ask you whether or not this pattern is a sequence is geometric, and the only way that it is a geometric series is if each of the values that are exactly the same is if we can multiply or divide it by a certain number. So the only way that works out is we have to take a look at the first values that they're given to us. So here for A we have 4, 9, 14, 19, 24, 29, 34. So the way to find out if it's geometric, first thing I have to do is I have to take 9 divided by 4. Well, 9 divided by 4 is like 2.25. So the only way that this is going to be a geometric sequence is that if I take 14 divided by 9, I get 1.5 repeating. And so since they're not the same, I can say that this is not a geometric sequence. So now if I look at B, I have 8 over 9, comma, and then the next one is 8 over 3. So if I go 8 divided by 3, and then I divide it by 8 divided by 9, I get a value of 3 here. So if I take 8 and divide it by 8/3, well, I get 3. So if I go 8 divided by 8/3, I get 3. 24 divided by 8 is 3. Yes, that's true. And if I take 27 and divide it by 3, I get 24. Yes, I will. So this is a geometric sequence, and the common ratio, which is denoted by r in this case, will be 3. Which this is, if you look here on the bottom, this is the rule for geometric sequence. So if we have a sub n, that equals a sub 1, whatever the first value is in our sequence, times it by r, which r is the common ratio, and then that is to the n minus 1 power, so it's like an exponent. So for these examples, they want us to find the use the equation to find the pattern, and then let's find what a sub 6 is going to be. So first thing we have to do is find out what r is going to be. So r here is going to equal, so first off, let's take 12 divided by 3. That's going to give me 4. 48 divided by 12, that's also going to give me 4. Let's see if 192 divided by 48 is going to give me 4. Yes, that's true. So now we know that for example A, our common ratio is going to be 4. So now what we get to do is we get to plug this back into our formula. So I can say a sub n equals 3, because that's a sub 1, times it by 4 to the n minus 1 power. Now if I'm looking for a sub 6, like they're asking for, I can say that it's going to be 3 times it by 4, and then it's going to be to the n minus 1 power, so that means it's going to be to the 5th power, because n is 6, so 6 minus 1 is 5. So if I go 4 to the 5th power, that gives me 1024, multiply that by 3, means a sub 6 is going to be 3072. Okay? So if I look at B, I have negative 12, divide that by 36. that's going to give me a negative 1/3. If I go 4 divided by negative 12, that's also going to be a negative 1/3. So my common ratio here is going to be a negative 1/3. Now when I want to write my a sub n here, I go 36, which is a sub 1, times it by the common difference, which is negative 1/3 to the n minus 1. So now when I'm looking for a sub 6 in this case, I get 36 to the negative 1/3, and n is 6, so 6 minus 1 is 5. So now I need to find what negative 1/3 to the 5th power is, and that's about negative 1 over 243. And if I multiply that value by 36, I get a fraction that looks like a sub 6 is going to equal a negative 4 over 27. Okay? Just like we had in 12.2, we are given one value in the sequence, and then we're also given our common ratio. And what they want us to do is find what a sub 1 is and then put it, give it the rule to the nth term. So very similar to what we did in the previous section. So we'll get to use our general equation, which is a sub n equals a sub 1 times it by r to the n minus 1 power. So we know that a sub 5 equals 54, so I can write out 54 equals a sub 1 because I don't know what that is. I know what r is, that's going to be 3. And then it's to the n minus 1 power. Well, n in this case is 5, so I can say that this is going to be to the 4th power. So from here, I can go, what's 3 to the 4th power? 3 to the 4th power is 81, so I can say 54 equals a sub 1 times it by 81 here. So now I can say 54 divided by 81, that gives me what? 2/3. So I'm saying that a sub 1 here equals 2/3. So I can write my general equation as a sub n equals 2/3 times it by 3 to the n minus 1 power. Okay, let's look at B. Same thing goes. Let's put it into the general equation. So they tell us what a sub 12 is. So I'm going to say that that's 120 equals a sub 1 times it by 1/2, which is my r. And then it's going to be raised to some power. Well, it's the n minus 1. Well, n is 12. So 12 minus 1 is going to give me 11. So 1/2 to the 11th power gives me some really small number. And what I'm going to do here is I'm going to take, 120 and divide it by that. So 120 divided by that really small number, and that gives me something really large. So that means that a sub 1 is going to equal 245,760. So if I put this into a general equation, I go a sub n equals 245,760 times it by 1/2 to the n minus 1 power. Also, just like we had in the other section, we were given two terms. The other day, we were using it to solve for, we used the elimination method to solve for the common difference with arithmetic sequences. Today, I want to use the substitution method in order to find the common ratio. So how we do that is, let's put it into the general equation using those two values in the sequence. So if I go 45, that's going to equal a sub 1 times it by r to the, well, it's going to be to the n minus 1 power. Well, n is 3, so it's going to be squared. And then the next one's going to be 405 equals a sub 1 times it by r, and it's going to be to the 5 minus 1, which is going to give me 4. So what I want you to do is this. You're going to substitute. I want you to get a sub 1 by itself, but I want you to get a sub 1 by itself with the equation that has the lowest um, value of power for r. And in this case, it's this one here because it's r squared. R squared has a smaller exponent than r to the fourth. So in order to get a sub 1 by itself, I'm going to divide both sides by r squared, which is going to give me 45 divided by r squared. So now I get to use the substitution method, and I'm going to put this value into this a sub 1 here, so I get 405 equals 45 divided by r squared times it by r to the fourth. Now I can use my rules for dividing exponents with the same base. I can subtract both my exponents here, so I get 405 equals 45r squared. Now if I take divide both sides by 45, I get 405 divided by 405 divided by 45, which just gives me 9 equals r squared. And if I take the square root of both of these, r now could equal plus or minus 3. So plugging it back into one of these equations, now I can find what a sub 1 is. So I'll use a sub 3. So I'm going to say 45 equals a sub 1 times it by plus or minus 3 to the n minus 1 power, which happens to be 2. So, whether it's positive 3 or negative 3, it's going to be a positive value here. So I'm going to get 3 squared, which is 9. So I get 45 equals a sub 1 over 9 times it by 9, I'm sorry. So if I divide both sides by 9, a sub 1 here is going to equal 5. So then my general equation is going to be a sub n equals 5 times plus or minus 3 to the n minus 1 power. Okay. Last thing we have here is finding the sum of a finite geometric series. Finite means it has a specific stopping point. For A, the specific stopping point is 6. For B, the specific stopping point is at 8. And here's the general equation for us to solve that. We got S of n equals a sub 1 times it by the quantity of 1 minus r to the n power divided by 1 minus r. So if I look at this sigma notation here, if you pay attention to this portion of the equation, this looks awful a lot like a sub 1 times it by r to the n minus 1 power. So I can say that this is going to be my a sub 1, and this is going to be my r. Same thing goes for here, a sub 1 and my r. So by able to identify that, I can find the sum of my geometric series by using the equation. So if I go S sub 6, in this case, I can say a sub 1 is 4 times it by 1 minus 2/3 to the 6th power, because it's S sub 6, divided by 1 minus 2/3. And doing the math all the way across, the value that we get for S sub 6 in this case is going to be, I'm going to get 2,660 in the numerator divided by 243 in the denominator. And you get to do the same thing so I'll just write the general equation. So I got S of 8 for this case is going to equal a sub 1, which is 6, times it by, so it would be 1 minus 4 to the 8th power divided by 1 minus, be what, 4? So let's take a look at this one here. A sub n is going to equal 6. So if I got 4 to the 8th power here. So if I go 1 minus that, it's going to be what, negative 65,535 divided by 1 minus 4 was what, negative 3. So if I divide that by negative 3, I get what, 21,845. I multiply that by 6. My S of 8 in this case is going to be 131,070. Okay? And, excuse me, and that is being able to analyze geometric series and sequences. Hope this helps. Till next time.